Day 4 video, Equations and Inequalities Review, solving multi-step equations and inequalities. You really want to work backwards using the number properties actually to isolate the variable. We want to get the variable all alone. Step 1 is to always distribute first if you can. Step 2 is to combine like terms on each side of the equation. And then we add or subtract to move all the constants to one side and to move all the variables to one side. Then you can use multiplication or division to get the variable alone, and then you check using substitution. This is a review from last year, so you have done this before, and you guys are really good at solving equations. Graphing them on a number line. I'm going to go over this quickly. What you do for an equal sign is, say I want to graph -3. It is a single dot on -3. Filled in, because -3 is an answer. You don't have any arrows, it's just a value at -3. B is less than or equal to 15. We'll put 15 in the middle, 14 on one side, 16 on the other. It is a filled in circle because 15 is an answer, and it's all the numbers less than that, so it goes to the left. Greater than 6.1. I'm going to choose to use 6 and 6.2 as my other two numbers. Greater than, not equal to, open circle, and going up. A good way to remember that is that the little line, this was a Miss Stewart way to remember it, this little line jumps up and fills in that hole. Okay, so if there is no little line under there, then the hole doesn't get filled in. For 5.5 is less than y, I have trouble thinking about what this means when the variable is on the right side. 5.5 is greater than y, so that means y is really less than 5.5. So I actually rewrite it as y is less than 5.5, and then your arrow will match your symbol, meaning that the symbol is pointing to the left, and so your arrow is going to point to the left too. It's less than 5.5, so it's not filled in, and it's all the numbers below that, all the numbers less than that. I decided to make 5, 6, 7, and 8 extra practice. I'm not going to do those in the video just because I had so many problems, so many things I wanted to go over with you guys. For writing equations, you want to find the value of x so that each pair of polygons has the same perimeter. I'm going to draw a line here because I thought it was a little bit confusing the way it was set up. X plus 4, x plus 5, and x plus 2 are the sides of the triangle. And then x plus 3 and x plus 1 are the sides of the rectangle. And the way to think about this is that since the same sides are on the top and bottom, this is also x plus 3. And since the same sides are on the left and the right, the left-hand side is also x plus 1. And you want to figure out when these two perimeters are the same. Well, remember, perimeter means that you add up all the side lengths to find the distance around the outside. So what that means is that x plus 4 plus x plus 5 plus x plus 2, that's the perimeter of the triangle, has to be equal to x plus 1 plus x plus 3 plus x plus 1 plus x plus 2. There's 4 sides of a rectangle. The biggest mistake that people make is that they only count 2 of the sides in the rectangle because the other 2 don't have an expression written on them. Well, you know what that expression is. It's the same as the bottom and it's the same as the right. I'm going to do some combining of like terms here. I have 1, 2, 3 x's on the left-hand side. And when I add together my numbers, 4 plus 5 is 9, plus 2 is 11. On the other side, My variables, there are 1, 2, 3, 4 x's, so I put 4x. And then the numbers, 1 plus 3 is 4, plus 1 plus 3 again is 8. Okay. I've run out of room, so I'm going to move it up here. I have 3x plus 11 equals 4x plus 8. And then at this point, since you've done all your combining of like terms, you have to get all the variables on one side and all the constants on one side. So I'm going to move negative 3x onto the right-hand side. The reason why I'm doing this is because I end up with a positive number. So the only reason why I chose to move the negative 3x and not the negative 4x. And I'm going to move the minus 8. And so I get 3 equals x. And that's my value. And then sometimes they'll ask you for all the sides. They might ask you for the perimeter. And you can just plug in 3 everywhere you see an x. Here are some types of equations. No solution. When you have like 4 equals 0. That's not true. 4 does not equal 0. So if you end up with that at the end, there is no solution. When you have two numbers that do not equal each other at the end, it doesn't work. No solution. One solution is the kind that you've seen many times. It was the majority of 7th grade. And then at the end of 7th grade, I threw you guys a curveball. What if like 2 equals 2 at the end? Or sometimes you can even notice it when you get here. 4x plus 2 equals 4x plus 2. Those two sides of the equation are absolutely the same. So that means whatever you plug in for x will work. So there's infinitely many solutions. If you notice, Common Core is a ton about the words. And so there's lots of words that mean equals, less than, greater than. And so we have a little chart here. When I get charts like this, I put them on flashcards. You might want to put the equal sign on the front of the flashcard, and on the back, write is the same as, is equal to, is. Those are all words that mean equal to when you get a word problem. On a graph, what you're going to see is a dot. Just a dot, a filled in dot, and that means that it's equal to. Less than and fewer than looks like this. It's a less than symbol, and what you're going to see on a graph is a open circle going to the left. Greater than is going the opposite way, and you're going to see an open circle going to the right. Less than or equal to is no more than, is at most, maximum, at, or below. Lots of words that mean less than or equal to. And that's a filled-in circle going to less because it could be equal to that number. And then is greater than or equal to, is no less than, is at least, is at minimum, or is at or above, is a greater than or equal to. Reading is super important in math now. Most of the problems on the Common Core are word problems. When it says use the store key on your calculator to check, we will do a couple of them in class. When you see OYO, that means on your own. So the video is going to be 20 minutes long, and then you're going to have to do 3 problems on your own. You're going to do 1, 6, and 7. Those are the on your owns. And I'm going to show you how to do them. For number 2, for example, step 1, distribute. Do you see a number outside of a parentheses? Absolutely, I see it twice. 8 times 4q is 32q. 8 times 5 is negative 40. It's really 8 times negative 5. Minus 7q is equal to, and then we can do the other side. 5 times 5q is 25q. And then 5 times a negative 8 is a negative 40. Okay, distributing, done. How about some combining like terms on each side of the equation? I'm going to notice that I have a 32q and a negative 7q on that left-hand side. So I'm going to combine those to get a 25q minus 40. Okay. At this point, I'm noticing that the two sides are exactly the same. So it does not matter what I plug into q. The two sides of the equation will be balanced, and it will work. So this has an infinite number of solutions because you can plug in anything you want, and it will work. 3 looks intimidating. And I'm sure it looks intimidating because of those fractions. But you're going to handle it the same way. And then usually with fractions, you'll have to get a common denominator at some point. So we have 1/2 r and then 2 times 3/4. I like to put that 2 over 1 so you can really see that it's 2 times 3, which is 6. And then 1 times 4, which is 4. So you're really dealing with 6/4 r. That will really help you to not multiply both the top and the bottom by 2, which is a pretty common mistake if you put 2 over 1. And then 2 times -1 is -2 equals 1/4 r plus 6. All right, so you're going to notice here that you have some combining that you can do, but I have a problem. One is in fourths and one is in halves. You can't add halves and fourths. So we're going to have to do some simplifying. You can either take 6/4 and reduce it to 3 halves, or you can take 1/2 and you can make it 4 halves. No, not 4 halves, 2/4. 2/4. So you can do either one. I'm going to probably change this to 3 halves. I'm going to change it to a different color so you know that I've just altered it. I've made that 6/4, 3 halves. And so now you can combine those. 1/2 plus 3 halves is 4 halves. 4 halves is really 2. Okay. We have an r on both sides, which is a problem. We need to get all the r's on the one side. And we have a constant on both sides, which is a problem. We need to get all the constants on one side. I'm still feeling like I don't have enough. Okay, so I'm going to do this so that I get a positive answer. So I'm going to minus the 1/4. Okay, so if you do 2 minus 1/4, you get 1 3/4 r. And then I'm going to do this part in green. I want to get all the constants onto the other side, so I'm going to add 2. And so I end up with 1 3/4 r equals 8. Okay, so what does that mean? Well, the 1 3/4 r we could rewrite as you could do 8 divided by 1 3/4. Or you could do the reciprocal, 1 3/4. I'll do that up here. Change that to an improper fraction. 4 times 1 gives you 4, plus 3 gives you 7/4. 7/4 r equals 8. So without a calculator, you could multiply both sides by 4 over 7. And that's using that multiplicative inverse identity. And you get 4/7. So your answer is r equals 32/7. Not a pretty answer by any means, but sometimes answers aren't pretty in real life, so it's going to model that. You don't always get a nice answer. So a lot of working with different common denominators to try to combine things together. So that was number 3. Okay, number 4 has an inequality. -5 times 3 is -15m. We're going to do some distributing. -5 times 6 is -30. is greater than negative 3 times 4 is negative 12m, and negative 3 times negative 2 is plus 6. Okay, and this is the minus sign. Okay, we're going to try to get all the variables onto one side. I usually like it so that the variable's on the left with an inequality, as you know, so that the symbol is going the same way as the arrow. It's just my personal preference. So I'm going to add the 12m. So you get negative 3m minus 30 is greater than 6. So then you got to add your 30. You can get all constants on the other side. You get negative 3m is greater than 36. Now, this is the part you always forget on me. When you divide by a negative with an inequality, the symbol has to flip. So the answer is actually m is less than negative 12. That is the tricky part about inequalities, is when you multiply or divide by a negative, the symbol flips. So 3 and 4 both gave us, well, 3 gave us one solution. 4 gave us more than one solution, but not infinite, just anything less than negative 12. And 2 gave us an infinite number of solutions. So you have kind of a grab bag here of all these different kinds of things that satisfy the equations or the inequalities. Some more distributing here. You've got negative 7k minus 63 equals 6k minus 30. You do your distributing. Alright, and then you can do a little tiny bit of combining, not much, just the 6k and the negative 6k. And so you end up noticing that you get negative 7k minus 63 equals negative 7k minus 30. So they're not exactly the same like they were in number 2. They're close, but they have a difference. They have a negative 63 and they have a negative 30. So if I add 7k to both sides, that actually disappears. And I get negative 63 equals negative 30. And I know that that's not a true statement, so that's a good solution. Okay. I did give you a fraction one to do on your own. See what you can make do with that. Please notice that a negative times a negative is a positive when you're doing that one. Pay close attention to that. And I'm going to do the fraction one with you because I have some tricks on how to multiply by fractions. 0.2x or 2/10 of x. And then this is interesting. 2/10 of 50. It's really 20% of 50. And I know 10% of 50 is 5 because I know that rule where you can move the decimal point 1 to the left to find 10%. So if 10% is 5, then 20% would be 10. So I can actually do that in my head. 6. And then what's 40% of 3? Well, a different trick. You could do 4 times 3. You would get 12. Oh, but one of those has a decimal. And so if I multiply by a decimal with one decimal place, then the decimal would go one spot from the left. So it's 1.2x. Same thing with 0.4 times 20. You're doing 4 times 20. 4 times 20 is 80, but then you have to have your decimal point one spot to the left. So it's 8.0 or just 8. So that's my problem, and then I want you to get all the variables on one side. Actually, there's some combining I can do first. Combine this times this 6. So your new problem is really 2x plus 4 equals 1.2x plus 8. And then I'm going to have you subtract the 0.2x. And the reason why I'm having you do that is because I want you to get one whole x over here. That'll make your math less steps. Not easier, just less steps. And then we want you to get all the constants onto the one side, away from the variable. Get that variable alone, and you get x equals -4. If you had subtracted the 1.2x, you would have ended up with a -1, and then you would have had to divide by -1 at the end. It was just one more step that, is unnecessary.